Hi everybody, this video today is going to cover lesson 8.9, which is on log expressions, logarithmic expressions. A log is the inverse of one of the functions. So inverses, remember, are opposite of each other basically. So addition is the opposite of subtraction, multiplication is the opposite of division. When you have the x to the squared, its opposite or inverse is square root. If you had x to the third, the inverse would be cube root. Well, what if you have a to the x? That is, what if it's exponential? Well, the inverse of an exponential is a logarithm. So there's a couple things about logs that we ought to pay attention to. One of them is, how do we even read this? So this middle one, for instance, or the second one maybe, the way we say this is the log base b of a is x. So the log base b of a is x. B is the base, x is the exponent, and a is the answer. So this means b to the x is equal to a. Well, we can rewrite that and say log base b of a is x. It kind of goes back and forth between the left and the right. And so a lot of times I will talk about going left, right, or right, left, right, depending on which form it's on. It's just you're going back and forth and back and forth and back and forth, depending on which way it is. So let's take a look at some examples. So to talk about these, I'm going to do that. I'm going to go left, or right, left, depending on which way. So this one, I'm going to go left, right, left. That means 5 to the second is 25. So when I say log base 5 of 25 is 2, that's kind of thinking in your head, 5 to the second is 25. Next one, 3 to the fourth is 81. So 3 to the fourth is 81. When I say log base 3 of 81 is 4, I think 3 to the fourth is 81. Or another way, 3 to what power would give me 81? Well, 3 to the fourth power would give me 81. All right, this one's kind of more basic. 9 to the first is equal to 9. 9 to the first is equal to 9. We're going left, right, left. Next one, 2 to the ninth is equal to 512. Once again, we're thinking 2 to what power would give me 512? And it would be 2 to the ninth would give me 512. And then remember that when we get into negative powers, fractions kind of go with negative powers, right? So what this means is 1/2 to the negative third is 8. Because remember, 1/2 to the negative third is actually flip this, and we get 2 to the third, and that's 8. So 1/2 to the negative third is 8. And 4 to the negative second is equal to 1 over 16. So log base 4 of 1 over 16 is negative 2. Now I've been saying you can go left, or right, left, right. It depends on what form you have. It depends on how it is in the context of the problem. Sometimes it's right, sometimes it's left, right, left. So if we look at this, if we change this over to log form, well, the base of the exponent, just like up here, remember we said the b is our base, so b is the base of the exponent. That becomes the base down here. So if we say this is like 3 to the fifth, base 3. So this is log base 3. I'm going to go left, right, left. Log base 3 of 243 is equal to 5. Okay, so we go left, right, left. And again, it depends on how this is written, because I could have written it the other way. 243 is equal to 3 to the fifth. In that case, I would go right, left, right. Just depends on how it's written. Okay, base 10 this time. So log base 10 of, go to the other side, we have a 1, is 0. Remember, anything to the 0 power is 1, right? So log base 10, base goes on the bottom, of 1 is 0. All right, this time, log base 10 again, of, other side, 10,000, is 4. And so again, 10 to the fourth means 1 with 4 zeros after it, right? So 10 to the fourth is 10,000, or log base 10 of 10,000 is 4. Take a second to try these last couple of them and see if you can write them out. All right, so this one, log base 6 of 1/6 is negative 1. 6 to the negative 1 power is 1/6. Log base b of a is x. I go back and forth between the sides. Log base b of a is x. And log base x of 1 is 0. All right, so that's some basics on how to change it over from log form to exponential form. The main reason we do that is because we are familiar with exponential. Logs are new, so logs are confusing to us. So if we can go back and think of how it really should be an exponential, it will help us to figure out the log. All right, in the next section, we're going to do some examples. So the first one, let me remind you of what this is asking. As we said at the very beginning, logs and a to the x exponents are opposites, inverses of each other. And so if they're inverses of each other, what they allow us to do is to solve some things. So we've been solving all these problems like in what year is it going to get to $10,000? And you had to go to the table and scroll through. Well, guess what? You don't have to go to the table and scroll through. You can find it using logs. But we just didn't know that a couple days ago. Now we know. Wow, we don't have to do that table anymore. We can just use a log instead. So that's what we're going to talk about. So when we see logs, like this first example, what we think of is 8 to what power is equal to 64. And I crossed out the equals x just because these have equals x, but in the book, actually, they're not always going to have that. So this is saying 8 to what power is equal to 64? Well, a lot of us in our head, or maybe on our little yellow sheet, know that 8 to the second is 64, right? 8 to the second is 64. So that means that the answer to this is 2. So that's what logs do. They allow us to figure out what power do we need to get to. Now, the reason I have the x's on here, even though they're not on the problems, is it allows us to use kind of that pattern we were using before, switching back and forth between the sides. So we could say 3 to the x power is 81. And now we have to think of, all right, 3 to what power is 81? Well, 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. I know that 3 to the fourth is 81, so that means that x must equal 4. Or in other words, log base 81 is equal to 4. That's my answer, is 4. Let's try another one. Log base 4 of 1/16. Ooh, fractions. Don't like that. That's all right. We can do fractions. We're going to change it to a power. 4 to what power is 1/16? That's what this is asking. 4 to what power is 1/16? Oh, fractions. We don't like fractions. But I know that 4 squared is 16. And so therefore, 4 to the negative 2 is 1/16. So there I have my answer. Negative 2 is what this simplifies to. 4 to the negative second power is 1/16. Let's try another one. Base 10, we're going to talk more about base 10 in just a minute, but base 10s are kind of easy. 10 to the x is equal to 100. Well, what power would that be? Well, squared. 10 squared is 100, so x must be 2. So 10 to the what power? Log base 10 of 100 is 2. Now, 5, 6, and 7 get a little bit more complicated. We have to actually think about things. Let me switch it over to exponential form. So we have 64 to the x power is equal to 1/32. Yikes. There is no power that's going to give me 1/32. But these both have a common base of exponent of 2. In other words, I know that 2 to something is 2 to the 6 is 64. So I can sub that in. And I know that 2 to the 5th is 32, so 2 to the negative 5th is 1/32. Now, because these both have the same base, the base of 2, couldn't we really say that 6x is equal to negative 5? And then if we just divide by 5 on both sides, divide by 6 on both sides, we would get our answer, x equals negative 5/6. And we could check that out on our calculator and see if it's right or not. And I'll show you that in just a minute. Another one like that, log base 9 of 27. So that means 9 to what power is equal to 27? And you might be thinking, well, that's 3. No, it's not. 9 times 3 is 27, not 9 to the third. Okay, but what common base do these have? These both have a common base of 3. So what this really means is 2x is equal to 3. Because when we have a power of a power, we multiply. So that's 2x. So I divide both sides by 2, and I get x equals 3/2. And again, I can show you some of these on a calculator here in just a second. Last one over here, 243. And I don't have my x here. That's okay. Let's put it in there, because I think that helps us to set it up. 243 to what power is equal to 1/27? Well, again, I don't know, but I know that 3 is a common base. 3 to the 4th is 81, so 3 to the 5th is 343. So 3 to the 5th to the x power is, all right, what about 1 over 27? Well, 3 to the 3rd is 27, so 3 to the negative 3rd is 1 over 27. And I'm kind of getting scrunched on space here. I'm going to come over here so we can see it. It's going to be 5x is equal to negative 3 because they both have a base of 3. So we just look at the powers. 5x is equal to negative 3. Divide by 5, and we get negative 3 over 5. So there's my answer. Okay, I had said I was going to double check some of these. So maybe, let's see, I'm going to double check, I think, number 6. Let's take a look at number 6. I'm going to bring up my calculator, and we can see if number 6 is right. So basically what I'm going to see is 9 to the 3 halves. What is 9 to the 3 halves? I'm going to do that on my calculator. So I'm going to come over here and go 9 to the 3 over 2. Enter, and it is 27. So I got it right. We will work on these some more in class. I know these are not easy. Hopefully 1 through 4, you were able to follow those pretty well. 5, 6, and 7, those are harder. We'll work on those some more. Okay, when we work with logs, we have something called a common log, and that is log base 10. Log base 10 is the common log. And if there is ever a time when there's not a base written, the base is assumed to be 10. So sometimes you'll just see log of 5. Log of 5 means log base 10 of 5. And so each of these is going to be like a 10th power, like a base 10. So you're asking yourself 10 to what power would be 100? And isn't 10 times 10 100? So that's to the second, right? So that's a 2. Now, in addition, the common log is on our calculator. Let me show you where that is. So on your calculator, over here by the 7 button, there's a log. And so if you type in log, and we were doing 100 a second ago, so log of 100 is 2. Okay, so that's where the log button is. Notice there's a 10 to the x above it because 10 to the x and logs are inverses of each other. In addition, right below that is the ln button, which we're going to get to here in just a second. And the inverse of L to the n of ln is e. So that's on there as well. Let's go back to our notes. Okay, the log of 0.01. 0.01, if we said that the right way, wouldn't we be saying 1/100th? Isn't that what that means? Okay, so if log base 10 of 100 is 2, then log base 10 of 1 over 100, or 1/100th, is negative 2, right? So 10 to the negative second is 0.01. So I can do that a couple ways. 10 to the power of negative 2 is 0.01. Or I can say log base, or log base 10. So log of 0.01 is negative 2. All right, so we can check it on our calculator. Okay, here is a 10 that has, or a 1 that has 4 zeros after it. We're base 10 still, and so this must be 4, because 10 times 10 times 10 times 10 is 1, 2, 3, 4. 4 zeros. 1, 2, 3, 4 zeros. So that is 4. On the other hand, we have this one, which is tenths, hundredths, thousandths, 10,000ths. So this is the 10,000ths place, and so isn't it negative 4, right? Okay, then we have a thing called natural log. A natural log is actually, in some ways, almost more common than the common log. If you watch the Better Explained video, they talked about E quite a bit, and natural log, ln, is the opposite, the inverse of E. What that means is, well, a couple things. One thing is, instead of writing log base E of x, we could write it that way, but nobody does. And so instead we write it the natural log, that's an ln. When I write ln, I usually make a cursive lowercase l, because to me that looks like a 1. And if you write 1n, it gets confusing. It's not, it's ln, all right? So one thing is natural logs and e's are inverses of each other. So the natural log of e to the first is 1. Let's try these over on our calculator. And again, this is not 1n, this is ln, natural log, natural log. Let's try the natural log of e to the third and the natural log of e to the 99th and see what we get. So I'm going to clear this off my calculator. Then the natural log button is over here by the 4. And so if we say the natural log of, now the E button is the inverse of, it's the second button for the ln. So the natural log of e to the third is 3. Let's try to the 99th. Natural log of e to the 99th is 99. So natural logs and e's are inverses of each other. So I'm going to go back to this page. The natural log of e to the third is 3. The natural log of e to the 99th is 99. They are inverses of each other. You might take a second to write that down so you remember it. Now, the natural log of 5 is what? And what we're asking is e to what power is 5? And I have no idea, because remember that e is like 2.781. I don't know. But my calculator does know. So I'm just going to show you how to do it on your calculator. That's what this is asking. The natural log of 5 is 1.609. All right, 1.609. X equals 1.609. Now, another way to say that would be, like I said up here, e to the 1.609 is 5. But our calculator can just plug it in. The natural log of 5 is 1.609, approximately. Log of 22. Okay, so these were both natural logs, but I want to show you that your calculator can calculate the decimal value for log of 22 as well. So this time let's use the log button by the 7 and ask what is the log of 22, and it tells us 1.34. What does that mean? Well, what that means is 10 to the power of 1.34 is equal to 22. And we can check that real quick. So if I go 10 to the power of 1.34 is, well, it was 21.877 because I rounded. If I did 10 to that power, I could go up and grab that, remember? So 10 to the power of, and I'm going to scroll up and grab that and copy it. So I enter it, and now it goes there. And if now I hit enter, it gives me 22. Again, logs and 10 to the powers are inverses, just like e and ln are inverses. All right, this, I know that e's are new to us, logs are new to us, natural logs are new to us. We will have some time in class to practice. You have to kind of get your mind wrapped around how to think backwards to do some of these problems. But that'll be a good mental exercise for us, and we will do some of that in class next time.